This is your chemistry class. We are in session 2 of the chapter periodic table. In this session, let us discuss about the modern periodic table. Here, Moseley had given, the scientist named Moseley, he had given the modern periodic law, which states that the physical properties and the chemical properties of the elements are the periodic functions of their atomic number. If you can recollect all the previous classifications like Dobereiner law of triads, law of octaves by Newland, and Mendeleev's periodic law, all those were based on the atomic mass, and this is the classification which is based on the atomic number. So Moseley says that the physical properties and chemical properties of the element depends upon the atomic number of the elements. And when the elements are arranged in the increasing order of their atomic number, when the elements are arranged in the increasing order of atomic number, the elements with similar properties are repeated after certain regular intervals. Means when all the elements are arranged in the form of a periodic table in the increasing order of their atomic number, those elements which are having similar properties, they are repeated after certain regular intervals. And the modern periodic table contains 7 periods and 18 groups. If you can recollect again, in the Mendeleev periodic table there were same 7 periods and there were 9 groups. But now the 9 groups became 18 groups. So the size of the periodic table is increased. So that is the reason why we call this one also as the long form of periodic table or the extended form of periodic table. So this is the modern periodic table. So before discussing the main points of the modern periodic table, you just observe the outline of the periodic table. So how it looks like. Because if you have good grip on the periodic table, you can answer many of the questions of this particular chapter. Just have a look for 10 to 15 seconds. Let us now discuss the main features of the long form of periodic table. There are 7 periods in the modern periodic table, and the number of elements present in each period are as follows. The first period contains 2 elements, and that is hydrogen and helium. As the first period contains only 2 elements and that is the smallest among all the other periods, that is the reason why first period is also called as the shortest period or very short period. The second period as well as the third period, both of them contains 8 elements each. The second period starts with lithium and ends with neon. The third period starts with sodium and ends with argon. And as they are relatively shorter than the other periods, so second and third periods, they are called as the short periods. The fourth period and the fifth period, both of them contain 18 elements each. And the fourth period starts with potassium and ends with krypton. The fifth period starts with rubidium and ends with xenon. And these two are called as the long periods. And the sixth period, it contains 32 elements starting from cesium and ending with radon. And this is the longest period in the entire periodic table. So we call it as a very long period or the longest period. And the seventh period is incomplete as some more elements are to be discovered to accommodate in seventh period. Now let us discuss the same thing by looking into the periodic table. So this is the first period. This is the first period which contain hydrogen and helium. And there are only 2 elements. And this is the second period starting from lithium and ending with neon. If you can count the number of elements, they are 8 in number. And the third period, sodium to argon. Again, count the number of elements, they are 8 in number. And you can see that some gap is present in that particular period in between the elements. So that is the reason why the first period, second and third periods, we can call them as discontinuous periods. Then the fourth period starting from potassium and ending with krypton. If you count, you get 18 elements here. Same, the fifth period from rubidium to xenon, another 18 elements here. Now if you count the number of elements in the sixth period here as it is, from cesium to radon, you are getting only 18 elements. But sixth period contains 32 elements. So where are the remaining 14 elements? I think immediately you must get the idea that there are some elements which are present below the main periodic table, and they are lanthanides as well as actinides. We shall discuss about them exclusively in next session. Now you must know one thing, these lanthanides exactly belong to 6th period. So 6th period in the main block contains 18 and extra 14 as lanthanides. So total number of elements in the 6th period became 32. Then in the 7th period, starting element is francium and ending element is the element with atomic number 118. Again, the 14 elements actinides, they are to be included in the 7th period. So now we can say that the maximum number of elements that can be accommodated in 7th period are again 32, same as that of the 6th period. But as of now it is incomplete period as all the elements are not being discovered, but the maximum elements that can be accommodated in 7th period are 32. Let us now see how to remember the first element and the last element present in each and every period. I think you already know what are the elements which come under the first group of the periodic table. Come on, tell me those elements. They are hydrogen, lithium, sodium, potassium, rubidium, cesium, and then comes francium. And you also know the noble gases which are present in the last group in the periodic table. And those noble gases are helium, neon, argon, krypton, xenon, and radon. And we shall leave after that one. Hydrogen is the first element of the first period and helium is the last element of the first period. So hydrogen and helium, in this particular way you can remember easily. And lithium is the first element of second period and neon is the last element. So similarly, third period sodium to argon, fourth period potassium to krypton, fifth period rubidium to xenon, sixth period cesium to radon, and seventh period starts from francium. So in this way you can remember the starting and the ending element of each and every period. The main important point here is why the first period contains only 2 elements and why the second and third period contains 8 elements each, and the fourth and fifth period contains 18 and the sixth and seventh period contains 32. Why can't the sixth period accommodate 18 or why can't the fourth period accommodate 32? We shall discuss that particular point here. In each and every period, in all the elements of that particular period, the valence shell is the same. I repeat, in every period, in all the elements of that particular period, the valence shell is the same. Means in all the elements of second period, the valence shell is the second shell. In all the elements of the fourth period, the valence shell is the fourth shell. And in all the elements of sixth period, the valence shell will definitely become the sixth one. So that is the meaning of this particular statement. Then each period starts with an element in which the electron enters into S subshell of an energy level, and that period ends when the P subshell of that energy level is completely filled. I repeat, each period starts with an element in which the electron enters into S subshell of a particular energy level, and that period ends when P subshell of that energy level is completely filled. I will just explain this particular statement here. Here itself you will get the explanation of how the periodic table is being built. For that one, we need to apply the concept of the Hufbauer principle. I think you know the statement of Hufbauer principle, which states that always the electron enters into the orbital of lowest energy. So first let us write the molar diagram. 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, and remaining not required. 6s, 6p, 6d, 7s, 7p, 8s. This is the order how the electrons are supposed to be filled into various subshells of a particular energy level. So this diagram is called as the Molars diagram. Let us see how this is useful for building the periodic table. Now in the first period, the electron enters into only one S subshell. So that is the reason we know that the maximum number of electrons that can be accommodated in S subshell are 2. So that is the reason why there are only 2 elements in the case of first period. Once that 1s is completed, then the electron enters into 2s. Once 2s is completed, again you must start from this line and electron then enters into 2p. So from 2s before 3s, what are the various subshells present? They are 2s as well as 2p. Maximum electrons in S subshell 2, maximum electrons in P subshell 6. So total number of electrons are 8. So that is the reason why the maximum number of elements that can be accommodated in second period are 8. Now see the third period. Even though the third shell contains 3s, 3p as well as 3d, then still only 8 elements are being accommodated in the third period. Let us see why. So before 4s means the third period starts with 3s, then comes 3p. So before 4s we are not getting 3d. So that is the reason why the electron first enters into 3s, then 3p, and then comes 4s, and then comes 3d. So in between 3s and 4s there is only 3p. So in third period the electron enters in this order, 3s and 3p. And as you know, again both of them together accommodate maximum 8 electrons. So third period also accommodate maximum 8 elements. Again, what are the various subshells in between 4s and 5s? So first is 4s, this is completed. Again start here 3d and then comes 4p. In fourth period we come across 4s and then in order we get 3d and then we get 4p. Now again maximum 2 electrons in S subshell, and tell me what are the maximum number of electrons that can be accommodated in D subshell? They are nothing but 10. Then P subshell again 6. So total makes 18. So that is the reason why there are 18 elements in the fourth period. So if you see in second, third and fourth here, second, third or fourth, in all the cases the first electron is entering into S subshell of that particular energy level, and the period is completed when the P subshell of that particular energy level is being completely filled. So that is the reason why we are getting 8, 18 elements, etc. Now let us see in fifth. Can you tell me how to fill the electrons in the fifth period? As first comes 5s, then comes 4d, then comes 5p. So 5s, 4d and 5p. Again it makes the same number of elements, total 18. Now the sixth period. What are the various subshells coming in between 6s and 7s? After 6s it is 4f, then comes 5d and 6p. So extra here is 4f, and the maximum number of electrons that can be accommodated in F subshell are 14. So that is the reason this total makes 32. And same pattern even in the seventh period, the order is 7s, 5f, 6d and 7p. That also makes 32. So in this particular way the periodic table is being built. So in each and every period we are supposed to learn the order of the filling the subshells. In second period the order is 2s and 2p. In fifth period the order is 5s, 4d and 5p and so on.